इधर आ जाओ। हसनैन क्या हाल है, ठीक हो? औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम अल्हम्दुलिल्लाहि रब्बिल आलमीन अर्रहमानिर्रहीम मालिकि यौमिद्दीन इय्याका नअबुदु व इय्याका नस्तईन इहदिनस सिरातल मुस्तक़ीम सिरातल लज़ीना अनअमता अलैहिम गैरिल मग़दूबि अलैहिम वलद्दॉलीन आमीन. Assalamu alaikum and good afternoon, ladies and gentlemen. Thank you very much again for coming here to attend the 12th lecture in series of Pakistan Society of Civil Engineers. Today's lecture would be given by engineer Abdul Waheed Mir, who is a very experienced engineer in Pakistan. He has 52 years of diversified field and management experience, not only in Pakistan, but in about 8 or 10 countries, namely Kenya, Tanzania, Libya, Iran, Nigeria, Indonesia, Oman, Afghanistan. Mir Saab has done his graduation in engineering from East Africa in Kenya, and then he proceeded to London, and he is a fellow of Royal Institution of Chartered Surveyors, and he's most probably, as far as I know, he's the only one, but maybe there are few others, but very few, who are the Chartered Surveyors, and they are fellow of Royal Institution of Chartered Surveyors. Mir Saab has served NESPAC for about 16 years. He retired as general manager from there, and after retiring from NESPAC, he has been an independent consultant on Ghazi Bharota project, Bhasha Dam, Neelam Jhelum Hydro project, and KKH upgradation projects. He is a visiting faculty at Government College University, Punjab University College of Information and Technology, Government Engineering Academy, and he has conducted 1-week refresher course at Kabul for engineers of Ministry of Energy and Power. Under USAID project, he has conducted survey and mapping training of Sindh Irrigation Department engineers in 1984. So today's lecture is role of geomatics on civil engineering projects, and I'm pretty sure this is a very interesting topic, and you will learn a lot from the lecture which inshallah Mir Saab will deliver now. Mir Saab, please proceed to the podium. And please welcome.
Bismillahirrahmanirrahim. Tahir Saab, thank you so much for your kind words. He has said a lot more than what I deserve. Tahir Saab is an old associate of mine. I had my office in this building for many years. Anyway, Geomatics is a new word altogether. Basically, it's a new terminology replacing the good old surveying and mapping. The reason the geomatics came about is the surveying and mapping is not the same surveying and mapping that was most of people practiced doing plane table survey or topographical survey manually and producing map sheets. Now you have computer related lot of data, you have remote sensing, and all that cartography work that was done manually is no more there. So they had to rephrase this profession, and it was decided that geomatics is the right word for it. Now, geomatics is the technique, profession, and science of accurately determining the terrestrial or three-dimensional position of points and the distances and angles between them. These points are usually on the surface of Earth, and they are often used to establish land maps and boundaries for ownership or governmental purposes. When we carry out same task underwater, say on river, lake, or seabed, then it is known as hydrographic survey. And as a matter of fact, it is of a large importance. It's of a very, very important subject these days to explore what is at the seabed. This is in the oil industry, or laying telecommunication cable, or laying the pipelines to get the gas and oil out of the drilling locations. To accomplish their objectives, surveyors use elements of mathematics, that means geometry and trigonometry, physics, engineering, and law. Surveying has been an essential element in the development of human environment since the beginning of recorded history, that is about 5,000 years. It is required in the planning and execution of every form of construction. As a matter of fact, if you look at what was done in Egypt by pharaohs, it's mind-boggling. They very accurately laid out the pyramids, and every year there used to be floods, and the land holding marking would disappear. So every year after the flood, invariably, Sarkar of the time would send out the surveyors to re-establish those agricultural land boundaries, which is cadastral survey. If you happen to go to Egypt, you will see on their palaces there are figures showing survey party carrying out the measurement tasks. Now that was for cadastral work. They needed that to collect the revenue. Now, and in addition to that, when you look at the pyramids themselves, they are very precisely laid out. Again, they must have had knowledge of surveying. Similarly, when you look closer to our own land, you will see a lot of monuments of the Hindu eras, particularly their temples. They are so precisely built, so precisely laid out, and one is forced to say that they could not have done it unless they had the knowledge of surveying. Similarly, I happened to be working in Indonesia and had the opportunity of seeing some of the old Hindu temples. And they were so precisely set out, so accurately laid out, that one wonders what tools did they use. Even we now, with all this technology and all these electronic gadgets, quite often do not get around to achieving the same quality of precision which they produced using very, very ordinary, old dated tools. One of the main things they had then was the plumb bob. Plumb bob and a triangle, wooden triangle. That's it. I'll show you a picture of that later on. Now, geomatics carries out a lot of different tasks. I have listed alphabetically the tasks which involves when you are doing a civil engineering project. You may have an archaeological site there which you need to protect. I give you an example of Psce Dam. Psce Dam reservoir will submerge lot of rock boulders with very fancy carving of various things. But the objective is they have made plans that all those rocks, rows of massive boulders, will be relocated at a safer place. So geomatics will be involved in that. Then you have aerial or photogrammetric survey. Now, aerial and photogrammetric survey is now going in the background. With the arrival of LiDAR and with the arrival of drones, it's a lot more cheaper, quicker to carry out the task which geomaticians used to do using photogrammetric techniques. Boundary survey, which is state and international, again, geomaticians are involved to lay out the boundary of the states and the international boundaries. Cadastral survey, every country, every government needs to do cadastral survey because that is the source of collecting land revenue. And again, here in our country, we have been using techniques to carry out cadastral surveys which are very, very outdated. And that is the reason. And our cadastral surveyors, which are patwaris, are so poorly trained that a lot of bloodshed and hera-pheri takes place. Now, I can quote you numerous examples. Take the case of Dasu hydropower project. There, the project is delayed because of lack of cadastral survey. The cadastral survey did not exist. So Sarkar cannot make payments unless we make cadastral maps. And to do cadastral maps, they engaged patwaris from other districts, from other areas of KPK to come over and carry out cadastral work. And what they do with the FITA, and at best, they asked us to provide them, the consultant provide them total station, which we did. And again, it is still slow process because the area is mountainous, area is hilly. Now, there were cases where it was not possible for the person to go up and take measurement. So we arranged for them a reflectorless total station. A total station which does not need a reflector at the far end. Okay, so that accelerated a bit. Still, Now we are coming to 8 years and cadastral survey is not finished. Now the thing that was recently proposed to them was to use drone. And I'll show you an example of that later on during the lecture. So this on civil engineering project, for that matter, any other project, even a gas pipeline project, or a transmission line project, or a road or highway project, you still need to acquire the land, and for that you need cadastral survey. Now and then come the deformation monitoring or movement survey of the structures. As civil engineer, you will know that all these major structures are susceptible to deformation. In the case of hydropower project, under the massive load of the reservoir, the dam structure can suffer deformation. And if the ground is poor, the vertical movement can take place in the form of sinking of the structure. So, and although a lot of geotechnical work is done, a lot of geological work is done, and a lot of drilling and whatnot is done, still it's never 100%. So the designer of the structures makes a provision in his design how much this structure can take. And for that, we have deformation survey. Precise points are set out, and accurate measurements in X, Y, and Z are taken to first degree standards. For instance, in the case of vertical movement, that means settlement or rebound, we use very precise leveling instruments which can measure to a fraction of a millimeter. Now, I myself have used that instrument, and it's time consuming, very time consuming. Luckily, now with the electronic age, we have same instruments, electronic instrument, which accelerates the rate of progress, rate of measurement. And for that, most of you must have seen the ordinary graduated rods in feet or meters. But these electronic leveling instrument, the rod they use is bar coded. There are no numbers, only bars are there. The instrument knows the reading. So when you look through the telescope, you point at the rod and you press the button, the instrument records the reading in feet or meter, whatever it is. It's the same thing that you see in the supermarkets, bar-coded things. So that has improved the quality of work and also the progress. Geological, as I said, geologists need to do mapping. So who does the mapping for them? A surveyor. Then hydrographical survey, inland waters and oceans. And lastly, but the most important thing, is the topographical surveys. The designer got to know the conditions, the shape and size of the terrain where he got to put his structure. On all civil engineering projects, we commence our planning with topographical maps produced by, in our country, Survey of Pakistan or some other agency. A common word used for such map is GT sheet. For your information, GT stands for Great Trigonometric Survey. Because when the British undertook the task of mapping the subcontinent of India, Pakistan and Bangladesh, it was considered at the time that nobody has ever done such a task before them. So they termed it Great Trigonometrical Survey, because trigonometry was the only tool then, mathematical tool. So the word GT sheet comes from that. Now, for surveying for a project, you need to establish a reference datum which is to be used for the work. What coordinate system to be used or adopted? We have one option is, which was the most common option, was to use the datum established by Survey of Pakistan, and of course the mean sea level established by Survey. I would like to tell you that, or inform you that mean sea level, to determine mean sea level, you need to undertake movement of the sea for over a period of almost 20 years. So you constantly see the high tide, the low tide, high tide and low tide. And over this period of time, then you establish the mean value for that. So it's not an ordinary task. You have to.
May we ask the question and at the same time questioning ask themselves?
You can ask one.
So the mean sea level is, variable. 20 years back, probably there would be different mean sea level, but would we hear that?
Yes, the mean sea level has been established. Okay, for a country, let's say for Pakistan. Now, due to environmental changes, the sea level has gone up. That is how we know. If we did not have the mean sea level established 100 years ago, we would not know if the sea at Karachi has indeed gone up. So the British established this datum maybe 150 years ago, 200 years ago, I don't know exactly when. So
that means sea level will remain same then?
It will remain the same. And this is the same for all the countries. Then only we know whether the country is sinking, like Holland. We all know it's sinking. Sinking with reference to the original datum. Okay, now the second system that is most common these days is UTM, Universal Transfer Mercator, WGS 84. Now, this is the most common reference system, coordinate system, which is used today, these days, for two reasons. One, it is used worldwide. All our remote sensing data, for instance, Google Earth is on that system. You can superimpose that. The other thing, it is convenient because we have a universal system as against previously we had one system in our country, Iran had another one, Oman had another one. Like this, every country had a slightly different coordinate system, which was a nuisance. Or when it's a small project, then we can also use local assumed coordinates. I have used during my career a lot of time for small project assumed coordinates. Now I must go back there. UTM, as I said, the biggest advantage is that you can superimpose your whatever you have done on Google Earth and readily know if it is okay, it agrees or not. Or when you acquire images from various vendors, remotely taken images, again, generally they are on UTM projection. Now, UTM projection, the elevation is different. It is orthometric level, orthometric height, that you need to convert to mean sea level. There's a mathematical formula for that. In fact, orthometric heights can be converted to mean sea level. There are softwares available for free on the net. So if ever you are given, for instance, GPS, when you take measurement with GPS, you get, of course, you can have in Survey of Pakistan system or UTM system or whatever. You tell it, it will do it. But generally, the GPS coordinates are generally are in UTM, WGS84, and the elevation that is orthometric height, which needs to be converted to mean sea level. I've said all this, we'll go on to, now,
Sir, what exactly is orthometric?
we come to that. Now, what were the different, until recently, the different methods and techniques used for horizontal control network, which means easting and northing? The traditional method is triangulation. Nearly all the world was covered by triangulation network. It's not used anymore because it has been replaced. It's a very slow process, very time consuming, and it has been replaced with traversing, particularly traversing using electronic distance measuring devices like geodometer, telerometer. So traversing, the advantage with traversing also is that you can establish control. You don't have to climb up the hills and establish beacons on top of the hills. Now, traversing can be open and closed. Now, open traverse is the most dangerous thing to adopt because you have no check on it. Remember that in geomatics or in surveying and mapping, we have built-in checks of all our measurements. Like, take the case of a triangle. A surveyor, if he takes 2 angles, he can complete the triangle. But no, in surveying, it's mandatory that you measure the 3rd angle also. So, there are some built-in checks and counter checks in this profession. So, open traverse is dangerous because there's no check on your work. That's why whenever you do traversing, you always have closed. Closed traversing doesn't mean you have to come back to your starting point. It can mean that you start off from a known point and you close on to another known point. That is also a closed traverse. The biggest advantage of traversing over triangulation is that it is run in the readily accessible areas, along tracks, roads, canal banks, railway lines, etc. Whereas triangulation, we need hilltops which are not available in flat plains of Sindh and Punjab. You know, when the British did triangulation, when they were in the plain areas of Sindh and Punjab, they would put up towers to do triangulation. And those towers were known as Bilby towers. But of course, you won't see them anymore They don't exist. They are not needed. Now, with the arrival of EDMs, of course, traversing has got a good boost. And of course, with the arrival of total station, it got further boost, because previously we used to have an angle measuring instrument, a theodolite, and on top of it, like somebody riding a camel, there will be EDM, a separate instrument. But of course, with the miniaturization, they have combined the two into one piece of instrument called total station. The biggest advantage, among other things, is that you can store your data on board your total station. Previously, we used to do booking on forms or in the survey notebooks, and there used to be a lot of reading and writing errors. But now, with the electronic instruments, the data is quickly and safely and accurately saved on board the instrument error-free, which is a very big plus point. Now, even EDMs and total stations are very rapidly being replaced by geodetic class dual frequency GPS equipment. You can get centimeter accuracy. As a matter of fact, using the right procedure, you can achieve elevation-wise millimeter accuracy, down to 10 or 15 millimeters. The biggest advantage of GPS is that you don't need line of sight. For traversing or triangulation, you need line of sight. You should be able to see your back station and your forward station. But with GPS, all you need is a view to the sky about 15 degrees up from the horizon, and that's about all you need. So GPS is very rapidly replacing even the best of total stations.
But as soon as this BGPS has also some problems, especially in forest areas.
Of course,
Like in
of course,
case where
of course,
there are high
of
mountains.
course. You got, as I said, you got to have view to the sky.
Yes.
If the view to the sky is obstructed by tall buildings in a city, or by thick forest, or by narrow valleys. For instance, when you travel along Indus, you come to a lot of places where the Indus Valley is very narrow. There you will get poor GPS signals. The minimum number of points that the satellites you must have, nicely placed, not like this, all three in one corner. Better they are well spread. Minimum is 3. But as in surveying, we always have redundant observation. So it's always desirable that minimum 4 satellites well spread should be available to get a good fix.
Can we take levels under water as well? We have kind of procedure where we can
Yes, but that is not that is not using GPS. That is using echo sounder.
Yeah, but that's also very old technique.
No, it's not old. Echo sounder is there. It's still there. Of course, there are more modern.
Replace this, there are some methods that we can take this survey, without going at the site, just like there are some drone and we can buy pictures and we can have that survey as well. But are there some methods that we can detect the bed level without going at a site? Because sometimes
You
few remote areas where
in shallow waters where there's no muck in it, you can get readings to the bed. It could be a river, it could be coastline, it could be a coastline of a reservoir, but only shallow and clear.
shallow being how much depth?
5 to 10 meters at the
5
most.
to 10 meters.
Now, vertical control, very important. How far are we with reference to the mean sea level? Survey of Pakistan has established permanent survey stations all over the country. But the unfortunate fact is that it's very difficult to get information from them because in our country everything is classified. So, but of course, when a government department asks the Survey of Pakistan, after following certain procedures and certain safeguards, they give you the data. As a matter of fact, this was the case until the arrival of GPS. Now we don't bother going to Survey of Pakistan. We set up our dual frequency geodetic class GPS. We set it up and let it run for 8 hours. And we can calculate elevation down to a few millimeters, mean sea level. So, सर्वे ऑफ पाकिस्तान की जाके मिन्नतें करने का ज़माना ख़त्म उनकी हज़ारादारी ख़त्म
But even we have to work very hard or try so much to get these images, these sheets, duty sheets.
Yes,
Because of these
security concerns, although I have said this many times to Survey of Pakistan people and to the Fauj also, you are living in fool's paradise. For 2 reasons. One, the original copies of GT sheets are at Dehradun, India, which was the center headquarter of Survey of India when there was no Pakistan and Bangladesh. Original sheets are with them. Now, one copy of those zinc plates is in Australia. During the Second World War, when the British got worried that Japanese are going to run through the India, what they did, they made a spare copy and shipped it on to Australia. So Australia has one copy of all the maps, and of course our copy is also with Dehradun. Now, that was the time when we did not have the remote sensing. Now, with the arrival of remote sensing, nothing is hidden. Nothing is hidden. You can go to Google Earth and you can see all the military installation which happen to be bigger than a meter, all the airports, all the bridges, all the dams, all the ordnance factories. But if you are caught taking a picture of ordnance factory, they put you in jail. I mean, it is stupid to put restriction in this age when remote sensing is so common. But that is the way things are. It's very difficult to change things. Maybe a World Bank expert will come charging them $20,000 a month as his fee, and he will advise them, and they will say, yeah, it's gore ne kiya hum kar lo. WAHEED Mir kali chamdi wala san kehna hai bakwas karda. This is unfortunate fact. Now, of course, for vertical control, we have the most common instrument is the automatic level. But even automatic level is, tell you the truth, is outdated now. With the arrival of electronic leveling instruments, nobody wants to use automatic level because it's so much quicker. And so much, there's no hassle of taking down notes. Readings error and booking error are eliminated. Now, there's a further advancement in leveling instrument thanks to the scanner technology. And now we have electronic leveling instrument. And instead of common graduated staff, we have bar-coded staff, which is read automatically by the instrument sensor, data stored electronically on board the instrument. Kahani khatam, very asan. Or jo aap kaam, what you used to do in one day, you can do it in 2 hours. Of course, the other methods are you can use total station to establish vertical control, but the accuracy will be poor. Barometer was used at a time for approximate elevations. And of course, these days, we can use handheld GPS for pre-feasibility stage, and you can get elevations which are good enough for that sort of work. Now, one very important thing is that when you establish on any project survey control network, ensure that it is permanent in nature. Because whatever you establish now and you use that to produce mapping, and the designer will design the project on it, and then somebody got to go and transfer that design onto the ground. And for that, you need the same old reference datum and reference point. During my career in Pakistan, I came into a lot of cases where they did not bother about leaving permanent marks at site, and we could not transfer the thing on the ground. Have to redo it. Of course, when you carry out topographical mapping, you got to define the area, you got to decide the mapping scale and contour interval, and method or technology to use for the mapping. Well, method and technology varies from project to project, from the financial resources available with the agency. Now, methods, for instance, is the ground survey using total station, or GPS in RTK mode. RTK stands for real-time kinematic. So what you do for total station, when you use total station for topographical survey, you set up your total station, and the rodman goes from point to point, and you take the measurements. Now, in this case, when you use GPS, you set up your GPS at the main station, and the other fellow, the remote GPS, goes from place to place and takes a reading. It does not have to be intervisible. Whereas in the case of total station, it was essential that are intervisible. So GPS is very extensively used these days in RTK mode to carry out mapping. It's much faster, as accurate as using total station.
So how much cost that equipment? I think that GPS and the other one which connects with the satellites. So what we call that instrument?
GPS takes the reading from satellites.
Okay, but there is another instrument I think which will connect to the satellites.
Yeah, well, you need 2 units minimum.
Okay, of GPS.
2 GPS unit. One will be on a tripod, and the other will be receiver will be on a rod with a controller. I'll show you pictures later on after that. And it is very, very fast and as accurate as anything you can do. Field operations, remember that field operations are costly affairs. To make things economical, you need to use this new technology. Saves time and money. The other thing is photogrammetry. Photogrammetry was a very popular tool until the arrival of satellite stereo imagery. Photogrammetry, although it's not abandoned, it's still used, but its use is very small now. Now, we use satellite stereo imagery, which means you have one picture and another one with this overlap, so you get stereo image. Now, the further development is using LiDAR. LiDAR is far, far more accurate than anything that we have used or done today. Because when the LiDAR instrument is fitted in an aircraft, it's a sensor which takes the data, and it literally takes millions of readings per second. So you get very good data using LiDAR. The aircraft flies and picks up the data.
So known as part of radar technology, or is it?
No, the radar technology was used for distance measurement. Telerometer was the offshoot of radar technology. South African scientists produced telerometer after the war, and they were purely radar principle. The Swedish produced geodometer. Instead of using sound waves, they used light waves. So in the case of geodometer, you had a reflector at the far end. In the case of telerometer, you have a master station and a slave station. Both, they send the signal and you get the signal back, and you take the time interval. But telerometers are not very common now. We have talked about this. GPS in RTK mode. Again, the advantage with this technology is that you can save the data on board the instrument and then connect it to your laptop or your desktop and download the data, and you can do computer-aided mapping. Against thousands and thousands of points, you can do that. Whereas in the earlier days, using total station, it was a time-consuming affair. Now, GPS is the tool of Spacage. In fact, it's an offshoot of the work they did for space. As I said, minimum you need 3 satellites. What actually GPS does is a distance ranging. You measure the distance from the satellite to the receiver. You have another satellite distance to the receiver. You have another satellite distance to the receiver. And if with the compass you draw those 3, where those 3 intersect is your position. Very simple as that. That is the basic principle. You know the position of the satellites. It is continuously updated with reference to the ground stations. The ground stations continuously are in touch with each and every satellite and informing it its position. And if you know their position and you know the distance, 3 arcs जब cross करेंगे, that's your position. Now here it is. 3 measurements. 3 spheres. 3 spheres where they intersect, and that's where you get your point. See, like this. This is the basic principle. The GPS is the process of continuous coordination between the ground station, space satellite, and GPS user. Now, of course, since these signals travel from the satellite through different layers of atmosphere, it suffers certain damage, deviation. And now it is very difficult to know how much deviation it has suffered. So what do? We have another station, let's say 100 kilometers away, we have another station, another GPS installed. And both the GPS are receiving the signals which are passing through approximately the same atmosphere. So if we know the position of our main station, that GPS will compare the new reading with the old reading, or to true reading, and he will find the difference. There is a correction. So through a radio link, the base station will convey to the rover station that beta, this is the correction you need to apply to your points. And this is called differential GPS. So you eliminate the source of error that you get because of going through the different layers of atmosphere. Okay?
So, excuse me, sir. When we use this technique for very small cracks, like in dams, so this.
Although technology is available now to do that, but we have not used it yet. Although there are a lot of published papers that say this and that, but it's possible, because in a case like that, you have your base at a stable, undisturbed location, away from the site and then you take the measurements. It's possible. Previously, for deformation survey, on all the projects in our country and other countries, we were using angle measurements or distance measurements using calorimeter, gyrometer, or total station and whatnot. But now it is possible to use GPS. GPS, dual frequency, in fact these days they even have 3 frequencies, and geodetic class. Now this is the control station which is constantly in contact with the satellite in the sky, and then it is sending the data to the receiver. Now GPS is extensively used while traveling in the open featureless desert, navigation of airborne crafts and sea-going vessels, and now it's very extensively used in surveying and mapping for geodetic survey control, flight line controls for aerial photography, or ground control photogrammetry, or for processing LiDAR work, or for processing satellite imaging. And of course, deformation survey for tectonics movement studies. GPS gives ellipsoidal height which needs to be converted to orthometric heights. Okay? So this is your topography, and the GPS is giving you this ellipsoidal height which you need to correct to get your orthometric height. That is, I'm sorry, I said the other way around earlier on. I said GPS gives you orthometric height. No, this is the other way around. Okay? This is it. Well, I've said, gone through this one before. 5, again the same thing. Now, this is a photograph of, we did this Iran-Pakistan gas pipeline project, and this is our base station, and that is our radio antenna for communication between the base station and the rover station. This is another, now this is the man with the rod and the receiver. This is again that Iran-Pakistan gas pipeline. This is a rover man. He gets his instrument at the backpack, in the backpack, and he walks. And he programs his receiver or controller that every 5 minutes or 10 minutes or 2 minutes, it got to take a reading. You don't have to stop and press the button to take a reading. It will automatically do it.
But he can miss the information if he sets the instrument according to time. So when he travels, so he might lose some information.
Well, if he's going very fast, if he's walking very fast, yes. But normally, the time spacing is such that invariably he collects a lot more than less. The chances of getting less are remote. Now, this is a drone image of model town Bank Square Market It's taken from 100 meter above the ground level. See how detailed it is. With this sort of image, you can of course do mapping therefrom if you want to. All you have to do.
Important things are elevation actually, how precise they are.
Yes, elevation also. You establish ground control points, X, Y, and Z. That is your ground control points, and use that. And now, this is a very interesting thing. This is image of a portion of the Dasu project site where they are going to build housing colony and offices. Now, you can use drone for cadastral work, and it will be far more accurate than anything we produce using conventional Patwari methods. Patwaris don't like this. Patwariyan di rozi de lat maar de. We try to tell them, look how accurate it is. Oh no, we cannot do that. It's not acceptable because उनकी रोजी को ठेस पहुंचती है. I mean, the state should get into this act. If they need to change the law of cadastral survey, they should do it and get rid of the fiddles of the Patwari work. I mean, everything is crystal clear. You can see your land, you can see your plot, you can see the limit of your. This should be made part of your land registry document. There was a lot of this talk about Punjab government has computerized the land record system. A lot of bullshit. If they want to, all they did was put in Excel format the data that was in their registers. What they need to do is produce things like this, which nobody can deny. And it is so easy to do it with this drone readily and commonly available. This is, I don't know why don't they want to do things right. It beats me. Now this is another image when we bought the drone. This is the first image we took. This is near Wabda town, Tarek Garden is a residential area. And we took the drone there and we took series of images. This is one of them. And look at how clear everything is. If you, for instance, if you own this piece of land, can anybody deny it? Can any Patwari cheat you on this? No, we can't. No, there's an urgent need that, and projects are getting delayed by the Patwari work, and the best example of that is Dasu hydropower project. It's 8 years and they have not yet acquired all the land they need. In fact, that project should have been producing power and earning money. For some reason, I don't know, why don't they wake up? Why don't our Sarkar wake up? This is another image of Tara Garden again. Look at the details. this is what they need for cadastral survey. Another image, we combine 2, 3, 4 images together to make this mosaic. Thank you for your attention. So I'll take any questions if you have.
Sir, will you inform us about cost of those imagineries if we want to take for our project? What is approximately cost of, per square meter? Of any
You
area?
mean drone images?
No, imaginary idea.
Yeah, imagery.
I belong to also NESPOX, sir.
Acha, acha.
Most of the time.
Well, then
we
you
have
should
to
ask,
pay some,
if you belong to NESPAC, then ask Imran, he will know the cost of it. No, I have that information, but I don't remember it. I have that image in the file, so many rupees or dollars rather per square kilometer. For imagery which is available in the archives is very cheap. The new imagery, if they got to acquire, is more expensive. And I have that. If you telephone me, I'll give you a look of it. But it is, again, it's much cheaper than
going there
Going-
and site and
I mean, we use satellite imagery, satellite stereo imagery to map 40 square kilometer area right next to Rico Dick concession. They have a concession which is again as rich as Rico Dick for copper and whatnot and gold. But the Balochistan government, they formed that company to explore it, but after a year or so, they dropped that project. Why? Is a big question. So before the project ended, they had the work done, and the imagery, I produced that. And from there, I produced contour maps of that 40 square kilometer area. Similarly, Tapi gas pipeline, we did some work on that also, but then the Fauj stopped the work because a foreign company was doing the LiDAR work, and the security was the main cause they stopped it. Anything else?
Thank you very much, Mir Saab. A very informative lecture, mashallah. So, gentlemen, ladies and gentlemen, if you have any questions, please go ahead.
I have a question on like how you're preparing the sheets for this photogrammetry stuff. So you show like the images of this Tariq garden and like all these regions. So this is like an image, right? Let's say a client wants to get like a photogrammetry map. So I'm assuming like, let's say I have,
produce that.
we can produce it,
Oh,
right?
no problem.
And it depends
You
on the
can,
client, right?
I wish I could have shown you very recently, within the last, you can say within the last 2-3 weeks, we took drone imagery of an area, a hilly at Fundar. Fundar is a place, some this 4 and 5 hours drive from Gilgit going towards Chatra. And software is available to produce contours. And we did produce contours for the client. And for that, all you need is a ground control points called GCPs. Because that software will use that as a reference to produce the contours.
So when I have that photogrammetry map, I will have the horizontal and vertical controls both, right?
Yes, yes. What used to have or still have 60% overlap. So that 60% overlap, you will see the image in 3D. Now, with satellite imagery and with drone, they tend to have 80% overlap. And you can actually see in 3D on the computer. You can make a model. You will see the hills and valleys, and then you can rotate. It's amazing what you can do these days. Something we could not even dream of when I was your age. It's just fantastic. This technology has revolutionized surveying.
Mir Saab is of the age where I think he has used the oldest instruments and now he's using the most modern instruments.
In my office, I have a cabinet which contains instruments which are over 100 years old. And some of those instruments, I'm not 100 years old, but some of the instruments I've used them myself. For instance, the calculating machine. When I was your age, we only had Psce calculating machine. All it was, Jama, Tafriq, or Zara. That was about all it did. And when I showed it to my son, who is educated civil engineer from USA, and I also showed him the slide rule. I go, what's this? Okay, your Empire State Building
Designed on that.
was designed using this thing, slide rule.
So, ladies and gentlemen, if there are no further questions, I will just give you an update on Pakistan Psce, Society of Civil Engineers. We have the membership tally today, alhamdulillah, is 120 for the associates. Students are 13. And regarding our publications, we have till September 7 newsletters and 6 magazines already issued, and those who are associates, they must have got these publications through email, and these are also available on our website. This month we had a special edition, apart from these newsletter and magazines, special edition of our newsletter which was on the earthquake. That was produced by our chief editor, Mr. Rizwan Mirza. If you haven't read that edition, do read it. It will give you good details of the earthquake which came in Mirpur, Azad Kashmir. So that is also available on our website. Our next lecture would be on 16th November 2019. It would be given by engineer Suhail Kibriya, who has just retired from NESPAC. He was the vice president there, and he worked in NESPAC in the geotechnical department almost all his life. So the topic would be bearing capacity of foundation on soils and rocks. So those who want to get registered for this lecture, you are most welcome to do it. Ms. Sadia is sitting outside, and she would be very happy to get you registered. So it is 16th November 2019. In my initial introduction, I just forgot to say thank you to our overseas viewers who are watching this transmission live on Facebook and YouTube. We had viewers from Australia, England, and I think 1 or 2 from Middle East. Thank you very much for your input and your taking out your time at odd hours to watch our transmission. Thank you very much for your support. So ladies and gentlemen, we come to an end of this lecture and this program. And most welcome. You are now most welcome to have a cup of tea with us. Thank you. Oh, certificate. Sorry. Law, why certificate? Sorry. I am sorry. Before we close, I have to distribute the certificates. उधर से रिजवान साहब को बुलाओ, आपके सर्टिफिकेट्स दें. रिजवान को बुलाओ. तुम तो पहले लेके यहाँ खड़े हो जाते हो, आज क्यों नहीं खड़े हुए थे? तो किसी और को कहना था. मैं भी कह रहा था कोई चीज किसी. रिजवान साहब, टुडे प्लीज हैव द ऑनर्स ऑफ डिस्ट्रीब्यूटिंग द सर्टिफिकेट्स एंड द शील्ड टू द गेस्ट स्पीकर. So today the honor for distributing the certificates and the shield to our guest speaker would be done by engineer Rizwan Mirza. Chalo ji. चल भाई साहब.
Thank you. Yunus Aziz Khan. Thank you. Mr. Mazhar Ali. Thank you. Mr. Muhammad Lukman. Thank you. Mr. Muhammad Khatib. Thank you, sir. Mr. Waqas Anjum. Thank you. Mr. Muhammad Aliyad. Mr. Zishan Ahmed. Thank you, madam. Fatima Hanif. Thank you. Qazi Muhammad Aslam. Engineer Kashif Sajjad. Thank you. Engineer Rehan White. Thank you. Muhammad Irshad.
Arshid.
It will misspell it. You have it revised. You will have difficulty with this. आपने मोटे में दर्ज लिखा होगा, ये आप बीबी के पास भेजें, इसे करेक्ट करें. स्पेलिंग मिसस्पेल किया हुआ फिर आपने.
नहीं सर, उनका ठीक है, वो अलग से है, वो सबसे शायद नहीं है.
आमिना सद्दीक. मोहम्मद अरशद.
ये आएगा ठीक.
ये ठीक स्पेलिंग. जैसे नाम का प्रिंसिपल ये है कि जो जिस तरह से लिखता है उसी तरह स्पेल किया जाए, इसे करेक्ट नहीं करते. आप यंग लोगों के लिए अगर मैं अपने नाम का तलफ़्फ़ुज़ गलत लिखता हूँ, यू हैव टू फॉलो इट. ये नहीं मुझे बता सकते कि इसका सही तलफ़्फ़ुज़ लिखने का तरीका ही है. सिकंदर हयात. अहमद EH से भी लिखते हैं लोग. इफ्तिखार हुसैन. शाकिर अहमद. मोहम्मद उस्मान. मोहम्मद कामरान जबीर,
बेटा और भी लेडी सिविल इंजीनियर को लगा करो,
मुबशर बाजवा, आपसे अब संभालने मुश्किल हो जाएंगे जो उसने कर दिया।
अच्छा अच्छा
हाँ,
चलो
अभी आपको उसका असर ट्रांसफर होने वाला है।
ठीक है।
मोहम्मद इमरान, राना मोहम्मद इब्राहिम, जफर इकबाल,
So now officially we come to end of this session. Thank you again for coming, and let's have a cup of tea together. Thank you.